Okay, this is A.SSE.2 Algebra, Seeing Structure and Expression, Standard 2, Video 1. We are going to factor some special products. Okay, here is a term I'd like you to know. Please copy this down in your journals and define it. We have some special product rules here when we deal with factoring. This is called the difference of two squares pattern. Difference means subtraction, and then we have two perfect squares on the ends of this binomial. And as you can see here, we have a product of two binomials with alternating signs. We have a subtraction sign in the first binomial and an addition sign in the second. They could be switched, obviously. We could have the addition in the first and the subtraction in the second. Regardless, what happens here is we lose the middle term. So if we were to FOIL this set of binomials, we would have a squared as the first term. We would have the last term of negative b times positive b, which is your negative b squared. And as you can see, that's what we started with. Now, why do we only have two terms and not the third term of the trinomial? Well, that's that outer and inner. So the outer term, when you multiply them, we had a positive ab, and then the inner term, when we multiply them, is a negative ab, and when you combine those two terms together, you get 0. So we actually have to take this and slide it over, and we lose the third term of the trinomial. And this is a pattern that you're going to be able to see when we come up with some examples. And these are quick tricks. So when you are factoring, you want to sometimes have this available quick trick to save you some time. And it's just recognizing the pattern. So let's practice a couple of these. The first indicator is a subtraction sign. It's a difference. And then the second indicator is that each of the terms are perfect squares. So noticing that, we can do the quick pattern. So x squared minus 25. I can put down my two binomials. Alternating signs, I could go either way. Minus plus or plus minus. The first term is a 1x squared. 1 is a perfect square, which is why we can use it. And then x squared is also perfect. So we say x times x. And then the 25 is your 5 times 5. Final answer. All right, the second one, the difference is an indicator. 4 and 81 are both perfect squares, and of course c squared is perfect. So we can quickly set up our binomials, alternating signs. The 4 would get us our 2 times 2, and the 81c squared would be 9c and 9c. 9 times 9 is 81. All right, the last one, well, it's starting with an addition sign, so we can't notice the initial indicator, but what we always want to do is factor out terms prior to looking for the pattern. So I'm looking at the first term being negative, so we've worked in the past with taking the negative out, and anything else that is common, like a greatest common monomial factor, we want to pull that out at the same time. So before we look for the pattern, let's factor out anything common. All right, so we take out the negative. 3 and 48 have a common factor of 3. 3 goes into both of those evenly. Now the variables, I have an m squared and a different variable, an n squared. So I can't factor out a variable. So let's go back in now. What would get me those two terms? Well, negative 3 times what gets me negative 3m squared? That would be m squared. And then what's going to get me this positive back? Well, if I took a negative out, that must mean another negative must be inside, because the negative times the negative would get me that positive here, which is what we started with. And then what's going to get me 48n squared? Well, 3 times 48 is 16, and then I have my n squared. Okay, we're not done yet. Because now on the interior of my product line here, I see the pattern that we were just working with. So we have the difference of two perfect squares. So I take out my -3. I have a product of two binomials. I have my alternating signs. I have my m and my m. And then I have what gets me 16n squared. That would be a 4n and another 4n. And there is your final answer with the factored out -3. All right, so that's our first pattern. We have two other patterns that can help us save some time. We have two trinomials. First indicator are your plus signs. You have your two positive signs between your A and B term and between your B and C term. And if you see that the ends are perfect squares and the middle term is double the product of the interior of your binomial, then you have this special pattern. And what do I mean by that product of the interior? Well, we've talked about that. Square the first, square the last. You multiply these two terms, A times B is AB, and then you double it. So if you double AB, you get two of them, two AB. So square the first, square the last, you multiply and double it. All right, and the same goes for the bottom. You square the first, you square the last. Well, what's a negative times a negative? That's a positive. Square the first, square the last, multiply, you get a -AB, and if you double it, you get a -2AB. All right, now how's that going to look with some examples? All right, first indicator, I have a plus and a plus between my terms. I have perfect squares on the edges, on the ends of my trinomial. So that must mean I'm going to end up with this, well, I'll write it out as two binomials for now, but we have a positive, positive, we have an x and an x, and then the square root of 4 would have to be our 2 and 2. And now if you were to FOIL it, you'd end up with this trinomial. So if I were to write it out correctly, I would have the x plus 2. How many of them do I have as a product? Well, it's squared. All right, so I can get rid of this one now. It's just a better way of writing your answer. It's shortened form. And see if it follows suit. Square the first, square the last, multiply, you get 2x, you double it, you get your 4x right back, and that's what we started with. All right, the second one here, well, I see an indicator of the opposite signs beginning with the minus and then the plus, so the subtraction and then the addition. That's a key for us. It's got to be in that order. But before we get going, I see that we can factor a number out, and that's always the first thing that you really want to do is factor out, make the problem a little easier to work with. So they all have a 2 in common. And when we get to the last lesson of this chapter, it's actually called factoring completely. So we have to be aware that there are a lot of steps to some of these problems. All right, so we factor out 2, and we go back in and we get a y squared. We get a minus 10y, right? We cut it in half, and then we have a plus 25. All right, let's think of our special pattern if this is even reasonable. Uh, the subtraction and then the addition, it's got to be in that order, like I said. The ends of the trinomial are perfect squares, so y squared is perfect and 25 is perfect. So that leads me to believe that we can have our quick answer of 2 times y minus 5 quantity squared. If you have trouble with that one, we could talk about that in class. All right, then, the last part of this lesson, something else we've worked with in the past is solving. Now, with the graphing of quadratic equations coming in the next chapter, we want to be aware of what the zeros are, and when we get graphing, we can talk more about the roots. So this is same idea. Let's find the quick pattern and then solve for the variable. That's what that equals 0 means. We're going to now find the values of x. Okay, so anything to factor out? No. How about a special pattern maybe? Okay, maybe. We have a plus, and let's look at the edges. We have a perfect square on one end and a perfect square on the other. So I think we can do one of those special patterns, and that would be the x plus the perfect square. 16 would get us a 4. That would be quantity squared, and that's equal to 0. So if I were to write this out completely to solve, that would be both of these equal to 0. So x plus 4 is equal to 0, or x plus 4 is equal to 0. Now that's just kind of silly to write it out twice. If x plus 4 is equal to 0, we only need one of them. What would x have to be to satisfy both of those equations? Okay, that would have to be negative 4, because negative 4 plus 4 is equal to 0. Okay, final answer. You only need one of them. X is x. All right, last problem. I picked out another one, and the idea that we have to factor out that negative a. We have a term here that has a negative sign. So let's get that negative out and any other common factor. And it looks like they're all even, so I definitely could take out a common number. And I think it's going to be a 2. So negative 2. I have an h and h. I don't have an h here, so I can't take out any h's. So let's go back in. I have an h squared minus, what's that going to get me? 14h, and then minus, let's talk about these signs now. If I factor out a negative and I put another negative in here, that would get me a positive. So that's not going to work. So if I take out a negative, I'm going to have to make up for that inside. So we have a positive, and then what am I going to have to do here to get back to the negative? Another positive. And then what's the half of 98? Well, that's going to be 49. Okay, so please be aware that when you factor out this negative and you go back in, you have to make up for that with your other signs to make sure that if you were to distribute this negative 2 back into your trinomial, you're going to end up with the original equation that you started with. So again, be very, very careful about how you do that. And now, if we're factoring this completely, we can't stop all the time. We did one step. That doesn't mean you're done. So let's look for anything that we can factor in this trinomial. Maybe it's one of those special patterns. I'll just tell you it is. I think you can see that. We have a negative 2. And which pattern is it? Well, they're both positive, and they're both perfect squares on the ends of the trinomial, which leads me to believe we have an h, and the 49 would get me the 7. So square the first is h squared, square the last is a positive 49, multiply it, you get a 7h, double 7h, that would be another 7h, which gets you the positive 14h, and that checks out. And now we're going to solve for the h. Well, we didn't take an h out, so I can leave that negative 2 alone. However, I do need to solve this square. This is h plus 7 squared for that h variable. All right, so you don't need to set both h plus 7's equal to 0. One of them would suffice. So if I'm solving for the variable h plus 7 equaling 0, h would have to equal negative 7 only. And there is your final answer. This will make more sense when we start graphing these trinomials, these quadratic equations. All right, in your journal, please define the given term on page 2 of the flip chart. You know, write down something that you learned that's new today from this video. Make a marking in your notes if you have a question. We can bring those questions to class and we'll answer them together.